Hey there, fellow space enthusiasts. Ready to blast off on another deep dive? If you're loving these cosmic journeys, make sure to hit that like button, subscribe to the channel, and click that notification bell so you never miss an episode. Today we're taking a close look at the giants of our solar system, the Jovian planets.
And not just the giants.
Oh yeah. We're also venturing into the realm of dwarf planets.
Those often overlooked celestial objects.
They're pretty fascinating in their own right. For this deep dive, we've got some incredible sources lined up. Research articles, mythological tales.
Even some historical anecdotes.
It's going to be an awesome journey.
Yeah.
And of course, I'm not alone on this adventure. Guiding us through the vastness of space is a true expert who can make sense of these celestial wonders.
It's a pleasure to be here, ready to unravel the mysteries of those distant worlds.
All right, let's set the stage. Imagine you're gazing up at the night sky. You see those bright points of light. Some are stars, sure.
But some are planets.
And not just any planets. We're talking about gas giants.
Colossal spheres of swirling gas.
They absolutely dwarf our own Earth.
These are the Jovian planets.
So what makes these Jovian giants so special? What are we even talking about when we say Jovian?
Well, the term Jovian comes from Jupiter, the king of the planets. And like royalty, these planets share some key characteristics.
Okay, like what?
They're composed primarily of gases like hydrogen and helium.
So vastly different from our rocky terrestrial home.
Exactly. And speaking of size, they're absolutely massive. If Earth were a grape, Jupiter would be like a basketball.
Whoa, that puts things into perspective.
And their grandeur doesn't stop there. These Jovian giants also have a ton of moons.
A ton. Like how many are we talking?
Some of them are even larger than planets in our solar system.
Okay, that's mind-blowing.
Yeah.
And our sources actually have this comparative table that lays out all the Jovian planets side by side. It's like a cosmic cheat sheet for understanding their unique personalities.
It really helps visualize the differences.
So let's start with the celebrity couple of the solar system. Jupiter and Saturn.
The A-listers.
I mean, Jupiter's the largest planet.
And Saturn has those iconic rings.
Every other celestial body is jealous.
Indeed, they're quite the pair. Jupiter's atmosphere is a swirling masterpiece of hydrogen and helium.
It's hard to even comprehend how big it is.
Now, Saturn, with its mesmerizing rings, is equally fascinating. They're made up of countless ice and rock particles,
Raging in size.
from tiny grains to massive boulders.
All orbiting the planet like a celestial ballet.
And when it comes to moons, these two are in a league of their own. Jupiter has a staggering 79 confirmed moons.
Wow, 79.
While Saturn is hot on its heels with 82, it's like a cosmic game of who has more moons.
Seriously, it makes you realize how much is happening out there beyond our little blue planet. And speaking of moons, one detail from our sources really caught my eye. Jupiter's moon, Ganymede, has its own magnetic field. That's the only moon in our solar system known to have such a feature.
It's an extraordinary characteristic. Ganymede's magnetic field indicates that it likely has a molten metallic core, similar to Earth's.
So what you're saying is Ganymede is basically a mini Earth.
In a way, yes. And get this, it's even larger than the planet Mercury.
No way. So it's a moon bigger than a planet.
It makes you wonder what other secrets are hidden beneath Ganymede's icy surface.
Right, it's like a whole other world waiting to be explored. And then we have Saturn's moon, Titan, which is equally intriguing. It's shrouded in this thick, nitrogen-rich atmosphere, which is quite unique for a moon.
Titan's atmosphere is so dense, it's actually denser than Earth's atmosphere.
What? How is that even possible?
It's a hazy orange world with methane lakes and rivers.
Methane, like the gas we use for fuel.
It makes you question our Earth-centric view of what a habitable environment could look like.
You're saying there could be life on Titan?
It's possible that life, as we don't know it, could exist in those methane lakes.
Okay, now we're venturing into science fiction territory. This is why I love exploring space. It constantly challenges our assumptions and expands our horizons.
Absolutely, and our journey takes us even further out now to the realm of the ice giants, Uranus and Neptune.
Pack your thermal underwear. So why are they called ice giants? What makes them different from Jupiter and Saturn?
Well, while they still contain vast amounts of hydrogen and helium, Uranus and Neptune have a higher proportion of heavier elements, like water, methane, and ammonia.
So they're like a cosmic slushy.
These exist in icy forms in their frigid atmospheres, hence the name ice giants.
Makes sense. And you know what else I find fascinating about Uranus? It rotates on its side.
Like it's tilted almost parallel to its orbit around the sun.
It's like it's doing a cosmic cartwheel.
That's one of Uranus's many quirks. Astronomers believe that a massive collision with another celestial object early in its history could have knocked Uranus onto its side.
Talk about a bad day.
Imagine the cosmic drama.
I can't even imagine. It makes you appreciate the incredible forces that have shaped our solar system. And then there's Neptune, the first planet discovered through mathematical prediction, not direct observation.
Talk about a brainy planet.
Indeed. So astronomers had noticed these irregularities in Uranus's orbit, and they couldn't be explained by the known planets. They suspected a hidden planet was exerting its gravitational influence. And through meticulous calculations, they predicted Neptune's location. And lo and behold, they found it exactly where they expected.
A true testament to the power of scientific reasoning and observation.
It's like they played a cosmic game of hide and seek, and they won.
It's a remarkable story.
And it underscores how our understanding of the universe is constantly evolving. We've come a long way since those early observations.
And there's still so much more to discover.
That's the beauty of it.
The universe is full of surprises. Welcome back, space explorers. I hope you're ready for more cosmic revelations, because we're about to dive even deeper into the wonders of Jovian planets and their enigmatic moons.
I'm strapped in and ready for liftoff. Last time, we journeyed through the differences between those massive gas giants and our own rocky planet. We even peeked at some of the unique features of Jupiter, Saturn, Uranus, and Neptune.
Yes, and we started to unravel the mysteries of dwarf planets, those celestial objects that challenge our definitions of what makes a planet a planet.
It's mind-boggling to realize how much diversity exists within our own solar system. So where do we go from here?
Well, our sources highlight some truly remarkable features of these celestial bodies, particularly the moons that orbit those Jovian giants.
Moons!
Some of these moons are so unique they make you question everything you thought you knew about space.
Okay, now you've piqued my curiosity. We touched on the fact that Jupiter and Saturn have a lot of moons, but I'm guessing there's more to the story?
Absolutely. It's not just about quantity, but the incredible variety and complexity of these moons. Take Ganymede, for example, Jupiter's largest moon.
Ah, yes, Ganymede, the moon with its own magnetic field. I'm still reeling from that revelation.
It's a feature that sets Ganymede apart from almost every other moon in our solar system. It suggests the presence of a molten iron core similar to Earth's, which is quite remarkable.
The molten iron core.
And remember, Ganymede is even larger than the planet Mercury.
It's like a planet in its own right, orbiting another planet. It makes you wonder if there are other Earth-like characteristics hidden beneath its surface.
That's the beauty of space exploration, isn't it? There's always the possibility of uncovering something truly groundbreaking. Now let's shift our focus to another intriguing moon. Titan, which orbits Saturn.
Titan, the moon with a dense, nitrogen-rich atmosphere. It's hard to wrap my head around the idea of a moon having an atmosphere thicker than Earth's.
It's a world shrouded in a hazy orange glow with a landscape sculpted by liquid methane.
Liquid methane?
Imagine instead of water, Titan has lakes, rivers, and even rain made of methane. It's like something out of a science fiction novel.
So you're telling me there could be liquid methane flowing on the surface of this moon right now? That's wild. It makes you rethink the possibilities of what a habitable environment could look like.
Precisely. Titan is a prime example of how diverse and unexpected the universe can be. It forces us to expand our understanding of where life, in forms we may not even recognize, could potentially exist.
Okay, that's enough to make anyone question their place in the cosmos. But let's not forget about those other fascinating planets, Uranus and Neptune. We talked about Uranus being tilted on its side. Do we have any clues as to how that happened?
Well, the prevailing theory is that a massive collision with another celestial object early in Uranus's history knocked it off its axis.
Knocked it off its axis.
It's a dramatic scenario, but it's the most plausible explanation we have.
It's incredible to think about the sheer scale of forces at play in the universe that could cause such a cataclysmic event. It makes our earthly concerns seem so insignificant.
It's a humbling perspective for sure. And speaking of humbling, let's revisit the story of how Neptune was discovered.
Ah, yes. The planet found through math. It's like a testament to the power of human intellect and observation.
Absolutely. Astronomers meticulously observed irregularities in Uranus's orbit, and through rigorous calculations, they predicted the existence and location of Neptune. It was a triumph of scientific deduction and a testament to the power of understanding the laws of physics.
It's inspiring to think that we can unravel the mysteries of the universe through observation and reasoning. Now let's shift gears and talk about dwarf planets. What sets them apart from their larger, more dominant planetary siblings?
The key difference lies in their orbital dynamics. Dwarf planets haven't cleared their orbital paths of other celestial objects. They share their space with other bodies of comparable size, creating a sort of cosmic traffic jam.
So it's like a planet that hasn't quite finished cleaning its room, still sharing space with a bunch of other stuff.
That's a great analogy. Planets, with their stronger gravitational pull, have essentially cleared their orbits of debris and other objects, establishing their dominance. Dwarf planets haven't achieved that level of cosmic housekeeping, so to speak.
So poor Pluto got demoted because its neighborhood is too messy. But it still holds a special place in our hearts.
Pluto is a fascinating world, full of surprises. Our sources reveal that it has a surprisingly diverse landscape, with mountains, plains, and even evidence of cryovolcanoes.
Cryovolcanoes.
Volcanoes that erupt with icy materials instead of molten rock. It's a truly alien landscape.
Cryovolcanoes. Now that's something I've never heard of. It sounds like something straight out of a fantasy novel. What about Ceres, the other dwarf planet we mentioned earlier? What's special about this one?
Ceres resides in the asteroid belt between Mars and Jupiter, and it's the largest object in that region. What makes Ceres particularly intriguing is the evidence of water ice beneath its surface.
Water ice.
Scientists believe that Ceres might have once harbored a vast subsurface ocean.
Water ice on a dwarf planet. That's a game changer. We talked about water being essential for life as we know it. Could Ceres have once been a haven for life?
It's a tantalizing possibility. The discovery of water ice on Ceres has sparked a wave of excitement among scientists searching for signs of life beyond Earth.
Wow.
It's a reminder that even in the most unexpected corners of our solar system, we might find clues to the origins of life itself.
It's mind-boggling to think that we've only just begun to scratch the surface of what's out there. From giant planets with their intricate systems of moons to dwarf planets with hidden oceans, there's so much more to discover.
And that's the beauty of it all, isn't it? The universe is an endless frontier of wonder and possibility.
It really is.
With every new discovery, we gain a deeper appreciation for the vastness and complexity of the cosmos.
Wow, what a journey it's been. We've traversed the realm of gas giants.
Jupiter and Saturn with their mesmerizing rings and countless moons.
And we ventured beyond,
To the icy domains of Uranus and Neptune.
unraveling their unique characteristics.
And challenging our assumptions about planetary tilts and compositions.
We even took a detour to the fascinating world of dwarf planets, like Pluto and Ceres,
Sparking a conversation about what truly defines a planet.
and where we might find those elusive hints of life beyond Earth.
It's been an incredible exploration, full of unexpected twists and turns.
Absolutely. But before we wrap up this cosmic adventure, there's one more celestial object I'd like to touch on. It's something that's been guiding humanity for centuries. A beacon in the night sky that has captivated stargazers and navigators alike.
Ah, you're talking about the pole star, Polaris. That
Yeah.
seemingly unwavering point of light in the northern hemisphere.
You got it. It's amazing how this one star has played such a pivotal role in our understanding of the cosmos and our place within it.
The pole star's significance goes far beyond its simple appearance. Its fixed position in the sky, due to its alignment with Earth's axis of rotation, has made it an invaluable tool for navigation, exploration, and even cultural storytelling.
It's like a natural compass, guiding travelers across vast oceans and uncharted territories.
Precisely. For centuries, sailors relied on the pole star to determine their latitude and maintain their course. Even today, with modern navigation systems, understanding the pole star remains crucial for astronomers and astronauts in orienting themselves in space.
It's fascinating how this one celestial object has connected humanity across cultures and time periods. I remember reading about how in Indian mythology, the pole star is called Dhruvatara and represents unwavering determination and steadfastness.
That's a beautiful example of how celestial objects have woven themselves into the fabric of human cultures, inspiring myths, legends, and a sense of awe and wonder.
It makes you realize that we're all connected to something larger than ourselves, part of a cosmic tapestry that stretches back billions of years.
Indeed, contemplating the night sky, with the pole star as our guide, reminds us of the vastness and mystery of the universe, and our own small but significant place within it.
Well, dear listeners, this brings our deep dive into Jovian planets, dwarf planets, and even our celestial guide, the pole star, to a close. We've uncovered incredible facts, challenged our perceptions, and hopefully sparked a sense of wonder about the cosmos.
We've journeyed from the largest planets in our solar system to those smaller, enigmatic worlds that defy categorization. We've explored moons with their own magnetic fields and methane rivers, and we've looked back at our own history, tracing humanity's connection to the stars.
I hope this deep dive has left you with a thirst for more knowledge, a desire to keep exploring and asking questions about the universe and our place within it.
And remember, there's always something new to discover. The cosmos is a vast and ever-evolving tapestry, and we're just beginning to unravel its secrets.
If you enjoyed this deep dive, be sure to hit that like button, subscribe to the channel, and click the notification bell so you don't miss out on future cosmic adventures.
Until next time, keep looking up, keep exploring, and keep wondering. Clear skies.